Okay, let's go back to the paper. Okay, let feel let some of the things we like to talk about next. Okay, so let's continue. We talk about two different problems that may encounter when we apply machine learning or neural network to network intrusion detection systems. Okay, the first one is the high cost of errors. Okay, we use confusion matches to explain it. The second part is lack of training data. But however, I think we might design a labeling process, okay, which might be helpful if you have only data, but you don't have labels. But you can do such kind of process to help you to do labeling. Okay, let's think second things. Okay, the third thing is the semantic gap between our result and their operational interpretation. As we mentioned before, a lot of times, okay, neural network or some machine learning algorithm, they are simply just some mix operation of addition, multiplication, non-linear function, okay, like neural network. But it is a little bit difficult for some people to comprehend what is the reason why we can use such a complex mathematics, okay, to map the x, which is our observation, to our target, which it might be a classification to a classification problem. So there is a semantic gap between maybe you can say between our x and y. However, from my opinion is that is like this. I think we talk about activation virtualization, right? We explained how a neural network where is it? Right. We talk about how a neural network, okay, they try to fold, twist, push, pull the original space, which is at the left hand side, okay, the purple and the red dots, okay, and those circles, by using those neural network weights and activation function to change, okay, to modify the original space and try to map it to some other space like this. Okay, we talked about this before. So we will have a very nice boundary line to help us to classify data in the original space, right? I think that is one of the explanation, but sometimes people don't I say some people just don't believe that it is good enough to do such kind of space transformation as an explanation of the to explain this. But for me, from my opinion, it is just kind of optimization problem. If your data is really, they can be classified in some way in the original space, and then we can come up a neural network which is very complex neural network that can map your data to the original space, to the random space, and we can classify them very easily, for example by using a boundary line in the random space to classify them. So basically for me, although those semantic gap might lost, for example, there are always some people that they will try to ask a question is that for example, we use this one, okay, for example, they may want to ask, okay, if we have a very nice neural network can map the data from X to Y. So could you tell me what is the most important features? For example, this one, XM. This is the most important features that can help us to map the original data to the Y. I think we talking about in logistical regression or regression problem. Okay, for regression problem, there is always a weight. Okay, follow on each feature, right? On each features. So we can use the absolute value, 就绝对值 absolute value of the weight to try to mimic, try to simulate, okay, how important this feature related to Y. Okay, we can use also this weight to do something, such kind of things. But however, we know those weights are just some way in the length space to fold the space, to rotate the space, to do that such kind of things, right? So of course you can use this way to answer the question. Okay, if the weight's absolute value is larger, and it is more important to detect to Y. Okay, and but for me, it is some way to twist the length space. Okay, and of course, some complex neural networks, which we will talk about next week. There is an important concept called attention. They will output a weight for each feature, so that we can use the attention value of each feature to answer the question, okay, how important this weight is to the answer Y. Okay, we'll talk about this next week. Okay, so I think or there's some recent research that talk about explainable AI. Attention is one of the way to approach explainable AI. So that in recent year, since there are a lot of people that are asking this question, okay, what is the semantic? What is the reason why we put this weight on certain feature? Why your neural network is look like this? It is a convolution. It is a dense layer. No matter what, there are some security. There are some experts. They are trying to answer such kind of question. What is the semantic between result and how to explain the model? So I think, of course, in 10 years ago, not many studies they focus on this part, but currently we are trying to fix it. Okay. Next one. Okay. This problem is not specifically talk about neural network. They talk about data, especially neural network data. Okay, enormous variety in input data. That means if you collect a lot of packets, okay, even if you have such kind of pre-processing process to do such kind of labeling, okay, there's always some new packets. Which is never seen before, because we have a lot of different protocols, we have a lot of different services. So as a network administrator, you have never seen such kind of packet before, right? So you have never modeled it before. So your autoencoder right here will view such kind of new packet as an anomaly. So it cannot correctly recover X and X prime. There's always new packet, new services, new payload, new headers have been invented if your data is network packet. So right here, there's always new data, new different kind of data, enormous variability of your input data. So the recommendation is still the same. Okay, if you have new data right here and your model is built on the type of old data, old observations, so you might need adaptive learned process, so that every week, every 1 week, every 2 weeks, or every month, you have to retrain your model. So right here, you have to retrain your autoencoder, you have to retrain your clusters again and again, so that your model will be much more reflect the current situation of your neural network. And again, as we mentioned in the previous hour, if you have such kind of adaptive learning process to refine your model, attackers know that, right? Attackers know that. So you have to make sure your model will not be attacked by the attacker. Not, I didn't mean you will never attacked by the attacker. I mean your model will be still solid, will still be robust, so that your attacker cannot attack your model. Sometimes, because attackers knows you apply certain neural network on your system, so you do some kind of intrusion detection on your system, so they will try to attack your model rather than attack your system. Okay, so I think there's some interesting figures we can find attack neural network model. Okay, we can see some, maybe that's some interesting. Yes, exactly this one. Okay, in current research area, neural network researches. Okay, of course we can build a model, create a classifier, so that we can have a very nice classifier in the random space, right? So here you can see that this very interesting things is that at the left-hand side it is an image. So you can create, for example, a convolution neural network to classify. Okay, that is a panda. So that you have several different animals as classes. So it says at 57% of the confidence that is a panda. Okay. However, attackers can can create noises right here. The noises can be appended to the original image. So this noise, okay, you can see that at the right hand side. At the right hand side, it looks like a panda as well, but actually the noise has been added to the original image, which is the left hand side image. Okay, so at the right hand side, human beings with our eye, it's still a panda, right? But basically, the image, the data, the vectors, okay, represent this image is a little different from the original panda. A lot of noise has been added to the images, so the right hand side. But if you put these images to your original, for example, a CNN convolution network models, and the result is 99.3% of confidence, it is not a panda. Right? It is not panda. There are several different I think there are several different examples. How did you create some noises? Okay, so we call it adversarial attack model. Okay, but I think it is not our focus right here. But actually, it happens. There are some researchers that are trying to attack your model. Okay, so that is okay. The next topic is fundamental difficulties for conducting sound evaluation. basically it's talk about data as well. We don't have very nice label data. So 10 years ago, they talk about at that moment, okay, that 10 years ago, they say there are only, I think, 2 public available network related data, okay, and there are only 2. So basically, if you would like to do some researches or publish academic papers related to machine learning and network security, only 2 data set you can use. So that it's very difficult to do such kind of researches because we have only limited data set. But however, as I in our web pages, okay, I provide some security data sources right here. Okay, you can say there's some awesome machine learning for cybersecurity, so you can simply just go to GitHub and say, okay, there's some data set, which is very nice for us. Okay, so I know you have hand in your project proposal, but if you want to change your data set, which is I think is still it is still nice if you want to use a more comprehensive or more complex data, you can choose one of them right here. Okay, one of the famous one is this one, is NSLKDB data. Okay, there are several training data, several testing data, and it's right there, and they are labeled, so you can use them to do your job. Or there's a KDB Cup 1999 data. Okay, and because it's a very large task, so I would, if you want to use this one, I recommend you use this the third one, the 10% data. Only 2.1 million of data is used, or you can even sample even less data in here, so you can do these things. Okay, again, for example, there are some data which is relatively more complex. Okay, there's some cybersecurity related data I can find right here. Okay, most of them I think most of them give you a lot of features about a packet or about session, or they give you some text data which is from spam mail, I believe. So you need to create a classifier to identify if it is a spam mail or it is not a spam mail, something like that. Okay, or it gives you the PE files as our homework. Okay, you have to make sure you can create a classifier to identify malicious PE files or normal PE files, something like that. So there are a lot of different data sets. Another one I would like to mention about is right here. I think that is important resources you should remember, which is right here, Google dataset search. Google provides a lot of research function, but this is the one of the new one, which is you can type some topics. For example, cyber security. Okay, it will try to figure out if there's any data set, not web pages, not images. That's data set. Okay, those data set can be used for your purpose. For example, I input cybersecurity right here. Okay, so maybe you can see, okay, this one is from Cargo. Okay, so we simply just go to Cargo and see what if it meets your need. Okay, it says it's a cybersecurity. I've never seen this before, so let's take a look at what is the data? Red team. Red team means it is maybe it is a context, or it is in the network environment. Okay, we have attack team and protect team. It's red team and blue team. Red team is blue team should set up several different services like HTTP website, file server, something like that. So the red team will try to attack those services. So basically they will record every packet, every sessions, every files in that environment. So that you may basically those information are recorded in such kind of environment. So so basically, but basically I don't know. I've never I don't know what this because this update 3 months ago. I haven't seen this before. So okay. So basically, they will record every attacks packet sent by the red team, which is the attacker. So okay, that's one of the things. Okay, so basically, if you know you have a specific topic you like to research, you have a specific data set you want to search, you may use Google data search to figure out if you can find useful data set. Okay, so let's go back to here. So basically, currently, okay, the data problems might be not. We can find a lot of data set from the internet. They are labeled. So from the point of view, the data problem might not that the impact of problem number 4 and number 5 and number 4 may not be that serious in current days. Okay, it's more friendly currently. So 10 years ago, maybe that is a very serious problem. Okay, but the problem number 3, the semantic gap. Some researchers that are trying to fix the things, so we're working on it. And lack of training data will be, it depends on, but if you have a specific problem need to solve, for example, you want to set up some classifier in your company, in the campus, in your lab, you might need to set up several different monitors to collect your data. It is still the problem. You might not be able to, for example, if I would like to monitor your, for example, cell phone. All right, your cell phone have many different apps. I would like to record every activities, every function codes, every files touched by the apps, every function code invoked, every program, every whatever. You have to record everything about this app in your cell phone. There's still be a problem that you don't have a monitor on your cell phone, because those cell phones, no matter it's Android, no matter it's Apple OS, iOS, it is very difficult to set up a monitor in your cell phone because it's not allowed. Okay, you have to break jail. You have to root your cell phone to do so. So not every environment is very friendly for you to set up a monitor to collect such kind of data. So problem number 2 is still a problem. Okay, and problem number 1, it depends on what kind of problem you want to solve, but most likely we don't want too much high false positive, and false negative. Okay, so that's the 4 problems mentioned by the Van Texen's paper. Okay, so I can skip this part. Okay, so basically the next part is right. I think in the introduction I cover all these problems, right? So Ali second part of this paper, they just simply just elaborate those problems. Okay, so I think we can skip this one because we talked about these things before. Okay, so I would like to show you, including right here, including they think to do anomaly detection by using machine learning technique is a little bit strange. Okay, the second one is right here. The B is that we have a very high cost of errors because we don't want attacks coming into our system, coming into our network. Okay, so we might want to have a very low, even zero false positive, but in that case, we might encounter very high false negative. Okay, C is right here. 10 years ago, we don't touch the semantic problems, but currently we have several different techniques, especially in neural networks. We'll talk about it next week. Okay, they will try to bridge the semantic gap between those weights and the answer. Okay, CD. Okay, the diversity of neural network traffic. Okay, new services, new packets will always come to our system, so your model should deal with these things. Okay, evaluation is right here. Okay, 10 years ago we locked off public available data, but currently we have more and more data. So if you want to write a paper, if you want to do some of your researches, you can find this data in the internet. Right. So I think that is okay. So here, even though it is a bit 10 years ago, okay, we have many different problems when we apply machine learning on IDS, intrusion detection, but there's still some recommendation that we can, okay, recommendation we should take into account. Okay, so right here, okay, one recommendation: understand what system is doing. Basically, so we have several different problems. Okay, right here. First, understand the threat model. Okay, what kind of environment does the system target? Okay, when we build our model, right? When we build our model, I think I talked about several times. If I would like to use a regression model, would like to use a regression model to know the relationship between your weight and height, right? I talked about this example before. When you do training, basically, if you are a children or you're an adult, right? The model of the children and the model which is suitable for adult, they should be different, right? So basically, when you need to know what environment your system target. So basically, when you do training and do testing, do validation, we use the word, okay, they should be in the same distribution, right? And as we mentioned before, the dots, the height and weight, the relationship between weight and height of adult should be different. The distribution should be different from the children's, right? So make sure. So right here, it says in a very small network, the problems, the models, the data collect should be very different from a large enterprise or even in the backbone network. So that is, the recommendation is make sure your testing data, your training data, your model, they are in the same distribution. Okay, and when you collect data, make sure all the distribution, all the data in the distribution you sample, you collect, is complete. Okay, I think I talked this before. If the distribution is like this, but if you collect data only in this part, it is very easy. It is very easily for you to create a linear model like this. But if your collection is incomplete, okay, you miss the red part, the right hand side part, so you don't know. So you don't know. You should not use a linear regression model to model the data you collect, even though your data at the left hand side is quite perfectly fit to your data. So that means if you try to model your data, you have to know what kind of environment your system target. Okay, did you collect enough data? Did your data cover the entire distribution? Is the sample, the method of sample is fit? You have to think about all the things. Then you create your model. Okay. What do missed attack cost? That depends. That is related to the confusion matrix. Okay. Currently, the loss function we use, okay, for regression model, we simply just use MSE, right? So as low as the MSE, and your model will be better, right? But sometimes when you have to think about if you want to design your own loss function, so that these two parts, if you have a very low MSE, it does not indicate that you will have 0 false positive or false negative rate. So maybe if your problem is very critical, so that you wish you have 0 false positive, which is right here, then I recommend you design your own loss function so that false positive can be minimized and even to be 0. If your model can if your model believe that okay, that if we have higher false negative, which is good, which is still good enough, and okay, also still I should not use good enough. If my problem need 0 false positive, so you have to tolerate higher false negative, which is your problem. Okay, which is maybe you have some other technique, some other model that help you to further examine, maybe the second model or the third model, to help you to examine those false negatives, so you can decrease the number of false negatives. You can further create the second model on this part, third model, the fourth model, which is okay, but you need 0 false positive. Maybe you have to do so. Okay, so that is what do missed attack cost. Okay, what skill and resource will attacker have? That means the attackers will try to improve their attack different ways to attack your system. So they know you have a model to monitor them. They know you have a model, so I said before, they will gradually change your model. So you have to be prepared. Okay, if they attack your model, how did you do that? Okay. Evasion means evasion 中文就是躲避、隐藏的意思哈，就是那个攻击会被隐藏起来。OK， in cyber attacks, okay, there's sometimes as we mentioned before, some attacks, okay, those attack intention are hidden in one packet or several packets, which is quite normal. But have you ever think about one thing is that if I send a packet to your services, which is a normal packet, okay, one times, okay, and again I send another packet, normal packet, to your system, okay, and so on and so forth. The third, the fifth, the fourth, the fifth, the sixth, the seventh packet. I'm not sure. Maybe I say maybe there is a very specific order that when you send those packet in a very specific orders, okay, and your web server, for example, may crash, okay, because server is written by someone like you and me, right? There are always some bugs, some vulnerabilities, and we don't know how to trigger those vulnerabilities. But maybe the hacker is so smart, so they know that if you send this normal packet in a very specific orders, and your server might crash. So sometimes it happens, okay, and I can tell you one of the interesting experience by my friend. Okay, he designed television, smart television, and as we know, if you want to interact with your television, smart TV, and you simply just use your remote, right, remote control. If you, he told me, okay, if you find some children, okay, it randomly push the button on the remote, okay, sometimes your smart TV might crash. But when we design the smart TV, we think, okay, you're just an ordinary, a normal person, right? You can push the button, different buttons, volume up, volume down, change it, switch the channels. But they never think about if you give the remote to a children or to a children, they just randomly push those buttons. It might, some vulnerabilities, some bugs might be triggered by such kind of random things. So that might happen. So I talk about is that even if your model can wellly describe some attack or wellly describe some normal behavior, there's always some exceptions. There was always some path. Okay, for example, if you use a finite state machine to describe your smart TV, right, and each event is the button, the signal received by the remote control. You always have something very strange that you never think about, but it might happen in the real world. So the system might look like this. So there's always something that you should fine-tune your model and try to create a better model to describe the, no matter it's a normal behavior or to describe the attack behavior. Okay, so there's another recommendation is that keep the scope narrow, which means don't, if you have we talk about two different types of detection, right? Anomaly detection and misuse detection. So that means but the recommendation is that in your company, in the campus, we don't simply just use one model, one concept, one approach to create our detection system. Basically, misuse detection has its pros, right? Its advantage is to detect null attacks, and anomaly detection model, its advantage is to detect unknown attack. So basically, we don't just use one of them, we merge them, we use both of them in our system. so that make sure your model is very small. You don't have to create a very big and one single model to solve all the problems. As I mentioned right here, okay? If you need the model to have a very low false positive, that's okay. You create this model, and you set up a very some loss function to make sure the false positive never happens. But you have a very high false negative, right? So what? You can create a second model, third model to solve such kind of high false negative problems. So make sure your scope is narrow, because when your scope is narrow, your model only tackle part of the problems. And as we mentioned before, if you have enough data in this very small scope problems, your model might have a very high accuracy. That is good enough. Then for the rest of the data which you cannot handle, you can pass it to the next model, and this model might collect data like this. Like the problem, the data, maybe some of the noises, some of the data that your model cannot deal with. That's okay. You pass those noises, those data you cannot handle to the next model, and the next model will be very focused on this specific noises or data, right? So that is okay. I think I can stop right here. I think that's all I like to share with you. There's always some problems with using machine learning for different security data. Okay, we stop right here, and so I think there it is. Okay, I think we cover most of the data right here. So I believe you have more. There's several different concepts you have to learn about. Okay, when we do intrusion detection, anomaly detection. So make sure you capture all this concept. Okay, so although it's not related to machine learning, indeed. Okay, but as I say, when you want to apply machine learning or neural network on data, when you go to a company, they give you a problem, you want to solve it by using neural network or machine learning, think about it. Okay, not necessary every problems, everything you need you try to solve, you need a neural network to solve it. Okay, maybe it is not feasible, maybe it is not practice, maybe you don't have enough data, maybe you don't know how to evaluate how good or how bad your model is. There are a lot of different problems may encounter when you solve the problem. So when you try to solve the problem, think about it before you design your neural network. Okay, here is the example on cybersecurity. So but basically there are detection problems, there are classification problems as well, so try to think about it before it. Okay, next week is our last week. Okay, I would like to talk about something about language model and attention model, which I talk about is how do we weight different features. Okay, when we use the language model. So I think that is the second most important in this class, because I think the most important thing is the learner space one. Okay, the activation. So after you know how learner space works, then basically different models, that's just different models, different ways to map your origin data to the learner space. So I think learner space is the most important concept you should learn in this class. And the second important thing is the language model. And the third thing is of course all the other algorithms. Okay, but algorithms is just algorithms. Okay, so we stop right here. Okay, that's it. Goodbye. See you next week.